Welcome to Today online class. Today we want to look at binomial. Okay. Welcome. So when we have x plus a all squared, then if we expand this is what we get. So what if you have x plus a raised to power 3? Then this simply means x plus a into so the topic is binomial theorem. As I've said earlier on, x plus a squared. That simply means that you have x plus a times x plus a. If we expand this is what we are going to get. So if a all cube, it simply means that we are going to have x plus a in 3 places. Then by the time we expand, we are going to get this. So what if we have x plus a raised to power 10? How do we expand this? We are going to have x plus a in 10 places, and it will be somehow difficult to do that. So under binomial theorem, there are two approaches that we can use to expand the power when it's in 10 places. The first one that we can use is called the binomial to know the coefficients. When we are expanding, it's called the Pascal triangle. We can apply Pascal triangle to be able to know the coefficients of the expansion. Or we use, if we don't want to use Pascal triangle, then we can go ahead and use the binomial expansion formula using the knowledge of combination. So I will start with the first one, Pascal triangle. Pascal triangle. So Pascal triangle will help us to know the coefficients of each of the powers. So this is the binomial. Binomial. Then we talk about the coefficients. Coefficients when we use Pascal triangle. So if we have x plus a, of course, we are going to have 1, 1. The coefficient of x here is 1. The coefficient of a is 1. Then if you have x plus a all squared. Under Pascal triangle, we are going to have, this is how to generate, we are going to generate the triangle. In this case now, this one, we write this one automatically. We now say 1 plus 1, it is 2. Then we put another one there. If you have x plus a raised to power 3, of course, that is when we have raised to power 3. That will be, we put this one. If we have 2 plus 1, 3, then you put another one there. If we have x plus a raised to power 4, of course, this will be 1 plus 3, 4. 4, 3 plus 1, 4. Then you put that one naturally. So if you continue in this order, we can also have x plus a raised to power 5. Then how do we get the coefficient of the expansion? We are going to have, we put this one there. 1 plus 4, 1 plus 4, that is 5. 4 plus 6, 10. 6 plus 4, 10. 1 plus 4, 5. Then put one. This one at the front and the one at the back comes in naturally. But how do we get it? No, this is the form of a triangle. It's the form of a triangle, and this triangle will actually help us to know the coefficient of each of these expansions. We can do that when we have up to x plus a raised to power n. But this partial triangle actually have limitations. Limitations in the sense that when this power is more than maybe 5, let's say 10, 20, then that is the limitation of this first approach under binomial theorem. I'm going to give about 2 examples under binomial theorem before we introduce the binomial expansion formula when we use either where we are going to make use of combination method. So I will want to take example on this. Why do we have this partial triangle? This partial triangle will only help us to generate the coefficients of each of these expansion. But by the time I have x plus a raised to power 2, we are going to write 1, will be depreciating with this power. Why this second one will be appreciating with this power? So let me just use example to get what we are going to do. For instance, when we have example 1, we say expand x plus 2y raised to power of 4. In this case now, the power is 4. So with the knowledge of partial triangle, we can know the coefficient of each of these. We can know the coefficient of each of these. Of course, the first one is when we have 1, 1. That is when it's raised to power 1. When we have raised to power 2, we are going to have 1. 1 plus 1, 2, 1. When we have raised to power 3, that is 1. 1 plus 2, 3. 2 plus 1, 3, 1. When we have raised to power 4, we have 1. 1 plus 3, 4. 3 plus 3, 6. 1 plus 3, 4, 1. So in this case now, the coefficient that we are going to make use of is when we have raised to power 4. So if you want to expand this now, we say x plus 2y. We say x plus 2y raised to power 4. This is going to give us, when we expand this now, x plus 2y, everything raised to power 4 will be equal to, this will be equal to, we first write out the coefficient 1, 4, 6, 4, then 1. That is how to expand this. Then what do we do? This first one x here will be depreciating, will be reducing with respect to this power. Why this second one, the second value here will be increasing with respect to this power? That is, I'm going to have x raised to power 4 multiplied by 2y raised to power 0. The first term increases with this power. This no, decreases with this power. Why the second term increases with this power? Here I'm going to have x raised to power 3. That will decrease from 4 to 3. Then this will increase from 0 to y to 1. 2 raised to power 2y raised to power 1 plus I will have x squared here. Then 2y raised to power 2 plus I'm going to have x here, 2y raised to power 3, then plus 1, x raised to power 0, 2y raised to power 4. So from there now, anything raised to power 0 is 1. So 1 times 1, 1, 1 times x raised to power 4. 2y, this y raised to power, that's 2y. 2 times 4, 8. Then I'll have x cubed y plus, this is 2 squared. 2 times 2, that is 4. 4 times 6, 24. Then this is x squared, y squared. Then plus 2 in 3 places, 2 times 2 times 2, that's 8. 8 times 4, 32. This is x, then y cube. Then lastly, we have plus x raised to power 0 is 1. Then 2 in 4 places, that's 16, y raised to power 4. And this will be the expansion. So this will be the expansion. With the use of Pascal triangle, we are able to expand this. But if you don't have the knowledge of Pascal triangle, what we are going to do is that you say x plus 2y times x plus 2y in 4 places before we finish the expansion. There's tendency that you make mistake if you don't have the knowledge of Pascal triangle. So that is how to apply Pascal triangle. Let's see another example. Say example 2. Example 2, when we use Pascal triangle to expand. In this case now, the question says using Pascal's triangle, comma, expand and simplify. Expand and simplify 3x minus 2 all raised power 5. So in this case now, we have 3x minus 2, everything raised power 5. So that Pascal triangle will only help us to know the coefficient. Then this first time we'll be reducing with respect to this power, while the second term here will be increasing with respect to this power. So if I use Pascal triangle, we know that this is 1 1 1 2 1 1 2 3 3 1. This is 1 4 6 4 1. Then this raised power 5. We go to the fifth one 1 5 10 10 5 1. So the coefficient that we are going to have here will be 1. The coefficient will be 1 5 10 10 1. That will be the coefficient. So pass. Then what do we do? This first time will be decreasing with respect to this power, while the second time will be increasing with respect to this power. Then, of course, it can be equal to 3x plus into bracket minus 2. So we can rewrite it in that form. So that the first one will be decreasing and the second one will be increasing with respect to this power. So what do we have now? This will be 3x raised to power, this is with 3x raised to power 5. 3x raised to power 5, then multiply by minus 2 raised to power 0 plus 3x raised to power 4 multiply by minus 2 raised to power 1 plus 3x raised to power 3 multiply by minus 2 raised to power 2 plus 10 into bracket multiply by 3x raised to power 2 multiply by minus 2 raised to power 3 plus 5 into bracket 3x raised to power 4 multiplied by minus 2 raised to power 4. No, this raised to power 1. Then plus, lastly, 1 multiplied by 3x raised to power 0 plus minus 2. No, multiplied by minus 2 raised to power 5. So if we expand that, minus 2 raised to power 0 is 0. Then we have 3x raised to power 5. 3 times 3, that's 9. 9 times 3. 3 times 3, 9. 9 times 9, 81. 81 times 3. This will give us 243 s raised to power 5 plus, here we are going to have 3x. We are going to have 5 into multiply by 3 raised to power 4. 3 in 4 places is 81. Multiply by 81 s squared multiply by, this is minus 2, multiply by minus 2. You see, dots connote multiplication. So I want us to do it step by step so that we will not make mistake. Then in this case, I'm going to have 10 multiplied by 3 in 3 places. 3 times 3, 9, 9 times 3, 27. That will be 27s cubed multiplied by minus 2 times minus 2. That's 4. 4 plus, we also have 10 multiplied by 3 times 3 is 9. I'm going to have 9s squared multiplied by minus 8. This is minus 8 because minus 2 in them plus, what do I have there? 5 multiplied by 3x multiplied by minus, that's 16. Then plus, this is 1. 3x raised to power 0 is 1. 1 times 1. Then multiply by, that is 1 multiplied by minus 32. Because 16 times, that's minus 32. Then at this point now, we can write out the question, the answer 243 s raised to power 5 minus times plus, this is minus here, 2 times 5, 10, 10 times 8, 80. That's 80 s raised to power 4 plus 70 s cubed. No, is more than 270. 270 times 4, that is 1080 s cube. 1080 s cube. Then in this case now we have minus times plus minus 10 and 9 times 8 72. 72 times 8, that's 720. 720 s squared. Then in this case we have 3 times 5 15. 15 times 16, that's 240. That's 240. I'm going to have plus 240 x, 240, this plus 240 x, then minus 32, and that will be the expansion. So if we look at this critically, this is what we are going to get. So the knowledge of Pascal triangle will only help us to find the coefficient of the expansion. Then once we know the coefficient, then this first one will be reducing with respect to this power. The second one will be increasing with respect to that power. Then we are going to take maybe the last example, say example 3, under Pascal triangle. So you can then go to a good textbooks, look for further examples. So in this case now, we have using Pascal triangle. Let me abbreviate Pascal triangle as PT. Expand 1 plus 2x raised to power 5. That is what we are asked to expand. Simplifying all the terms. That is the A part of the question. Then B, the B part of the question now say, use your expansion to calculate the expansion to calculate the value of 1.02 raised to power 5. Correct to 6 significant figure. Okay, so this is 2-in-1 question. The A part of the question, we want to expand 1 plus 2x raised to power 5. Of course, if we use the Pascal triangle that as we have shown the other time, this will be 1 5, just to get the coefficient of the expansion. This 1 5 10 10 5 1. So this first one will be decreasing with this will be increasing. So I will have multiplied by 1 raised to power 5 multiplied by 2x raised to power 0 plus 1 raised to power 4 multiplied by 2x raised to power 1 plus 1 raised to power 3 multiplied by 2x raised to power 2 plus 1 raised to power 2 multiplied by 2x raised to power 3, then plus 1 raised to power 1 multiplied by 2x raised to power 4 plus 1 raised to power 0 multiplied by 2x raised to power 5. That's what you get. Then from there we can go ahead and expand. 2 raised to power 0 is 1. Everything there will be 1 plus 2 raised to power 1, that is 2. 2 times 5 10. That will be 10x. Then plus, in this case 2 times 2 is 4. So 4 times 10 40. We have 40x squared plus, in this case now 2 in 3 places is 8. 8 times 10, that is 80 s cube. Then plus 2 in 4 places, that's 2 times 2 4 times 4 16. 16 times 5 is 80. We have 80 s squared. Then plus 2 raised to power 2 x raised to power 5, that will be 32 s squared, and I raised to power 5, and that is the expansion. That is the expression that we are going to get. So the question now says that we should use this to expand when I have 1.02 raised to power 5. Of course, I can split this to be 1 plus 0.02 raised to power 5. That's what I can do. So if this is 1, if you add 1 plus 0.02, it's same thing as this. Then can we compare? This is raised to power 5, this raised to power 5. We can go ahead and compare the two. That is this raised to power 5, this raised to power 5. I can say, when we compare what you have inside, we have 1 plus 2x here being equal to 1 plus 0.02. What can we say about what we have? So in that case, we can say this is 1, then this is 2x. If I subtract 1 from both sides, it will cancel out. So we are going to have 2x to be equal to 0.02. Then divide both sides by 2. So we can get the value of x to be 0.01. Then how do I simplify what I'm given? So I will now say b, which is equal to 1.02 raised to power 5 to be equal to 1 plus is 0.02 raised to power 5. Of course, I know that x is equal to raised to power 5. what would not be the answer? I will now write the answer. This will not be equal to, I will go to this expression. The final answer that I have for 1 plus 2x raised to power 5. This is the final answer. This is the expression. This is the expression. This is the expression. This is 32. This is the expression. I'll just write out the expression. Wherever I have x here, I'll change it to 0.02. So that I'm going to have 1 plus 10 multiplied by 0.01 for the value of x, plus 40 into 0.01 all squared, plus 80 into 0.01 raised by 3, plus 80 again into 0.01 raised by 4, plus 32 into 0.01 raised by 5. Then if I expand that, if I expand what I have on the board, if I expand that, I'm going to get 1 plus 0.0 is 0. That will be 1 plus 0.1 plus 0.004 when we expand this, then plus is 0.00008 when we expand this, plus is 0. In this case now, I'm going to have is 0.0000008, then plus the last one, that will be is 0.0000000 in 8 places, 32. Then if I hide everything together, I'm going to get 1.10408. That is correct to 6 significant figure. So you can check out the answer that I have here. So with the knowledge of partial triangle, we were able to expand 1 plus 2x. Then we now equate, we get the value of x to be 0.01. Just go ahead and substitute from that expansion, substitute 0.01 for x. You'll be able to solve this problem. And that is what we are asked to do. So as I've said earlier on, under binomial expansion, we can use 2 methods, Pascal triangle, or the second method is the binomial expansion formula. Binomial expansion formula. This binomial expansion formula has an advantage over Pascal triangle in the sense that if you have anything, if you have x plus a raised to power 20, and of course at the long run we are going to truncate, we know what to do. We don't need to generate any triangle before we'll be able to expand this. Then in this case, this is what we have. If you have x plus a raised to power n could be any value. It could be positive, it could even be negative, it can even be fractional. Then once it is negative, we cannot use partial triangle. When it is fractional, we cannot use partial triangle. But if let's say we have it in this form, then this is going to give us x raised to power n plus n combination 1, x raised to power n minus 1 a, plus n combination 2, x raised to power n minus 2 a squared, plus in that order. So at the end of the day, we are going to have plus n combination n a raised to power n. This is what you have. That is, what is the meaning of this? If you want to expand this, the theorem simply means that, of course, if you want to get the coefficients where we are using Pascal triangle, we are generating the digits. In this case, we are going to use the knowledge of combination. That is, I'm going to tell us the meaning of combination. That simply means that if you have combination, of course, there's a concept called permutation and combination. If you have n combination r, that simply means that this is n factorial all over n minus r factorial r factorial. What's the meaning of factorial? Factorial simply means you reduce that digit to 1. That is, if I have 3 factorial, it simply means 3 times 2 times 1. That's the meaning of 3 factorial. If I have 1 factorial simply 1 factorial, it is 1. Then 0 factorial is also 1. Let's take notes. 1 factorial is 1. 0 factorial simply means we reduce whatever factorial we are given up to 1. So here, if you have n combination r, combination has to do with selection. There's another one called permutation. Permutation has to do with arrangement. So combination, we have n combination r will give us n factorial all over n minus r factorial, and that is what we are going to get. So in this case now, this first one will be n combination 0. So the first one will be n combination 0. Then I will use example to explain that. So if you have this now, for instance, let me give digits now so that we'll be specific. If you have, let's say we have 5 let's say we have 5 combination 3. This simply means 5 factorial all over 5 minus 3 factorial 3 factorial. Then how do we reduce this? Since we have 3 factorial at the denominator, I will reduce this to 3 factorial. This will be 5 times 4 times 3 factorial. We stop here. All over 5 minus 3 is 2. That is 2 factorial. Multiply by 3 factorial. 3 factorial can cancel 3 factorial. At the end of the day, I have 5 times 4 all over. What is 2 factorial? 2 times 1. Once we get to 1, that's the end of factorial. Then 2 here 1, 2 here 2, 5 times 2, 10. That's what we are going to get. So that is just the simple analysis about combination. We are still going to talk about permutation and combination. So under this binomial expansion formula, this is what we generate. This x will be depreciating, reducing with n, and a will be increasing with n. But for us to be able to get our coefficient here, all the coefficients that we are going to have here, we are going to use the knowledge of combination to be able to get the the expansion. So I'm going to give example now to be able to expand to explain this binomial expansion formula very well. So let's say, look at example 4. This is the advantage that this one has over the other one. Or let me use the first example. Let me use the first example that I gave. That first example, the first example that I gave. Then the first example. Let me use the first example before I will take any other example here. So the first example that I gave, that is, let me check the first. Okay, let me check the first example where I have. Let me give this expand. Let me just say expand x plus 2y, everything raised to power 4. This is the first example that I gave. So in this case now, how do we expand this? How do we expand this? Of course, this is what we are going to get. X plus 2y raised to power 4. Of course, this first one will be decreasing with this, while this will be increasing with this. But how do we get the coefficient that we use Pascal triangle in the first example? In this case now, I'm going to get 4 combination. Here I'm going to get 4 combination 0, s raised to power n, s raised to power 4, multiplied by 2y raised to power 0, plus 4 combination 1. All this will help me to find the coefficient. In the first method, we use the Pascal triangle to get the coefficient. But when you are using this binomial expansion formula, we are going to use this combination to get the coefficient. So here I'm going to have s reduced to 3 here, then multiply by 2y raised to power 1, plus 4 combination 2. I will have s raised to power 2, then 2y raised to power 2, plus 4 combination 3. I will have s raised to power 1, 2y raised to power 3, then plus 4 combination 4, which is the last one. I will have s raised to power 0, 2y raised to power 4. Then how do we get this combination? 4 combination 4. 4 combination 4 will now give us 4 factorial all over 4 minus 0 factorial is 0 factorial. S raised to power 4, 2y raised to power, anything raised to power 0 is 1. So that one is out of it. Plus 4 factorial all over 4 minus 1 factorial, 1 factorial. S cube multiplied by 2y. Then plus 4 factorial all over 4 minus 2 factorial, 2 factorial. This will be s squared multiplied by 2 times 2. That is 4y squared, plus 4 factorial all over 4 minus 3 factorial, 3 factorial. X, 2 in 3 places, that will be 8y multiplied by 8y cube. Then lastly, we have plus 4 factorial all over 4 minus 4 factorial is 0 factorial. We have s, anything raised to power 0 is 1. Then this will be multiplied by 16y raised to power 4. So from here now, we have been able to expand this. So from here now, what do we get? I will now go ahead and solve this. So of course, from here, 4 minus 0 is 4. So 4 factorial can take care of 4 factorial. 0 factorial is 1. Then at the end of the day, we are going to have just s raised to power 4 here. Plus, in this case now, we are going to have 4. I can reduce, since 4 minus 1 is 3, I will have 3 factorial at the denominator. I can reduce the numerator to 4 times 3 factorial. Factorial simply means you reduce each step by 1 all over 3 factorial here. Then s cube multiplied by 2y. 3 factorial will cancel 3 factorial. We only have 4. Plus here, the 4 minus 2 is 2 factorial. I'll reduce this to 4 times 3 times 2 factorial all over 2 factorial multiplied by 2 factorial is 2 times 1. Then I will have s squared multiplied by 4y squared, plus here I'm going to have 4 minus 3. I have 3 factorial. That will be 4 times 3 factorial all over 4 minus 3 is 1 factorial. 1 factorial is 1 multiplied by 3 factorial. Then I'm going to have 8xy cube. Then lastly, I will have plus. Then the one I have here, this is 4 factorial. 4 minus 4 is 0. So this is 4 factorial all over 4 minus 4 factorial. Then this here is 4 factorial. So 4 minus 4 is 0. 4 factorial becomes 4 factorial. At the end of it, I will have 16y raised to power 4. So if I expand that further, if I expand this further, I'm going to get x raised to power 4. Here now, this is 4 times 2, 8, plus 8x cubed y, plus here now, 2 factorial cancel 2 factorial, 2 here 1, 2 here 2, 2 times 3, 6, 6 times 4, 24. I'm going to get 24 x squared, y squared, plus here, this will take care of this. 4 times 8, 32. I'm going to get 32, 32x y cube, plus the last one, 16 y raised to power 4. So if you compare the results that we get now, if you compare this result that we arrive at and the result that we got in that first example that I gave, you realize that we get the same thing. So you can use any of the method. We can use any of the method, but the superiority of this method over the Pascal triangle is that if the power of x is say let's raise to power 10 or 20, and we are asked to truncate, this is the best method. Because the limitation of Pascal triangle in getting our coefficient is that when the power is very large, like 20, 30, then we'll be restricted. So this binomial expansion formula is actually the best when the power that we have under the expansion is higher. So we have been able to show that irrespective of the method that you applied, we are going to get the same results. So let me give another example using this. I'll give another example using this binomial expansion formula. So let's get another example. Okay. So let's take another example. Let's take another example using this binomial expansion formula. Let's say example 5. So let's take another example. So the example says expand A is 2 in 1. Find the first 5 terms of the expansion of 1 minus s raised to power 10 in ascending powers of x. Now look at this question now. If you are to use Pascal triangle now, it will be somehow tedious because we need to expand that triangle up to raised to power 10. Then the second question now says using the expansion of A, that is whatever expansion that we got here, we have to find the value of 0.98 raised to power 10 correct to 5 dp, 5 decimal place. So solution. What are we given? 1 minus s raised to power of 10. Then from the question, we have to find the first 5. That simply means that I will only find the first 5, then I will truncate the expansion. Then if I want to do that now, of course, we are going to have, this is what we are going to have. We are going to have 10 combination 0. Of course, 10 combination 0 will be 1. But let me just put it that way. 10 combination 0, then this is what I have here, same thing as you saying 1 plus minus x, everything raised to power 10. So this one will be decreasing with respect to 10, and minus x will be increasing with respect to x. This combination stuff will help us to find the coefficients, just like when we use Pascal triangle. That's what we use here. Then this will be multiplied by 1 raised to power of 10 multiplied by minus x raised to power of 0, plus the second coefficient, 10 combination 1 multiplied by 1 raised to power of 9 multiplied by minus x raised to power of 1, plus 10 combination 2 multiplied by 1 raised to power of 8 multiplied by minus x raised to power of 2, plus 10 combination 3 1 raised to power of 7 multiplied by minus x raised to power of 3, plus this is 1, 2, 3, 4, then the fifth one, 10 combination 4 multiplied by 1 raised to power of 6 multiplied by minus x raised to power of 4, plus dot dot dot. because we are asked to find the first 5 terms. So this is the superiority of this method over the Pascal triangle, because if it's a Pascal triangle, we have to write it out everything. So this method is actually interesting. So in this case now, what is 10 combination 10? 10 combination 10 will be 10 factorial all over 10 minus 0 factorial. 10 minus 0 factorial is 0 factorial. Then one raised power, whatever is 1, then anything raised power 0 is 1. That's what you are going to have there, plus 10. This will be 10 factorial all over 10 minus 1 factorial, 1 factorial. Then plus, then no, 1. Then that will be multiplied by minus x, plus 10 factorial all over 10 minus 2 factorial, 2 factorial. Then I will have multiplied by minus x squared. Minus x squared is x squared, so x squared. Plus, we are going to have, let me continue here. Plus, I'm going to have 10 factorial all over 10 minus 3 factorial, 3 factorial. Then I'm going to have here multiply by minus s cube, plus 10 factorial all over 10 minus 4 factorial, 4 factorial. Then that's multiplied by s raised to power 4, plus dot dot dot. We have to truncate it after the first 5. So from there from there we are going to get this one now. This is 10 minus 0, that's 10 factorial. 10 factorial we cancel 10 factorial. At the end of the day, we have 1 here. Then minus, plus times minus. Then here we have 10 minus, I'm going to have minus 10 times 9 factorial, because I'm going to have 9 factorial here. 10 minus 1 is 9. So 9 factorial. 1 factorial is 1 minus x, plus here I'm going to have 10 times 9 times 8 factorial all over 10 minus 8 is 8. I'm going to have 8 factorial here. 2 factorial is 2 times 1 s cube, minus, because I'm going to have minus here, plus times minus will be minus. So I'm going to have 10 times 9 times 8 times 7 factorial all over 10 minus 3, 7 factorial multiplied by 3 times 2 s cube, then plus 10 times 9 times 8 times 7 times 6 factorial all over 6 factorial multiplied by 4 times 3 times 2 times 1, because factorial simply means to reduce it, s squared plus dot dot dot. So from here now, from this point now, I'm going to get 1. 9 factorial, we cancel 9 factorial, minus 10x, that's what we are going to get. 8 factorial, we cancel 8 factorial. Here 1, here 5. 5 times 9, 45. This will be plus 45 s squared. This is s squared. I have s squared here. Then minus here 7 factorial, we cancel 7 factorial. 3 here 1, 3 here 3. 2 here 1, 2 here 2. 2 here 4. 4 times 3, 12. 12 times 10, that's 120 s cube. Then plus, lastly, 6 factorial, we cancel this. Then 4 times 2 is 8, you cancel this. 3 here 1, 3 here 3. 3 times 7, 21. 21 times 10, that plus 210 s raised to power 4, plus dot dot dot. From the question, we are asked to truncate just to find the first 5, expansion of the first 5, and that's what we have gotten. So that simply means that 1 minus x all raised to power 10 is equal to what we have on the board. That's the expansion. Then we can go ahead and to the big part of the question. We have to find the expansion of 0.98 raised to power 10. What is 0.98? It's not the same thing as 1 minus 0.02. Everything raised to power 10. If you subtract it, because it's an expansion, so we just have to expand. Then this is raised to power 10. This is raised to power 10. We can equate. We can say 1 minus x is same thing as 1 minus 0.02. That is 1 minus 0.02. Then if we decide to do that, what can we say there? So we can realize that x can be equal to 0.02. From that expansion, s will be equal to 0.02. So that is 0.98 raised to power 10 that we are looking for. We just, it will follow, it's the same thing as this expansion. Just that wherever we have x here, we change it to 0.02. So I'm going to write it out from here. I'm going to have 1 minus 10 into bracket. Instead of x now, our half is 0.02 plus 4 into bracket 0.02 all squared minus 120 into bracket 0.02 raised to power 3, then plus 210 into bracket 0.02 raised to power 4 plus dot dot dot, because we are asked to truncate it. Then if we do that, At the end of the day, we are going to get 1 minus 0.2 plus 0.018. You check it out, minus 0.00096 plus 0.0000336. So if we express that, we are going to get the final answer to be 0.81707. So 5 dp, and that is what we are asked to do. So just go through standard textbook and get further example on binomial expansion. And lastly, I will briefly talk about linear approximation. So we can actually use the knowledge of binomial expansion to do linear approximation. I'll give just one example, then we call it a day. I'll stop the class. So under linear approximation, what do we do there? Linear approximation. Under linear approximation, this is what we do. If we have 1 plus s, everything raised per n, of course, we know what to do. The first one will be n plus n combination 1 x plus n combination 2 s squared plus dot dot dot. Then at the end of the day, this can be equal to 1 plus, when we find n combination 1, of course, that will be n factorial. N combination 1 will be n factorial over n minus 1 factorial 1 factorial. Then if I want to reduce it, this will be n into bracket n minus 1 factorial all over n minus 1 factorial. 1 factorial is 1. This becomes this. So n combination 1 is going to give me n x plus n combination 2 s squared plus in that order. Then I can, this is same thing as I can say 1 plus x, everything raised per n is approximately 1 plus nx, provided x is small. So that is the interpretation. That is what we are going to get. That is the simple interpretation of that. So under linear approximation, if we are given any question, we can just approximate. We can truncate every other thing, because the higher this the higher the power of x, the smaller the value of the expression that we have, and we can see that from the example that I've given. So let me just give the last example. Say example 7 or thereabouts. So the question says find the linear approximation. Linear simply means the degree 1. Linear approximation for, I'll give just 2 examples. For the first one, A, 1.005 raised power 10, then B, 4.01 raised power 3. Solution. This first one now, we have 1.005 raised power 10. What would this give us? From what we have there, from what this is same thing as you saying 1 plus is 0.005 raised power of 10. And that will give us, from the expression now, we said when we have 1 minus s raised power of n is same thing as 1 minus nx. From the linear approximation, this will now be 1 plus, here n is 10. That will be 1 plus 10 multiplied by 0.005. That's what we are going to get. At the end of the day, we have 1 plus is 0.05, and that will be 1.05. This is what we are going to get. Because if you have 1 plus x raised power n, the linear approximation that we got is 1 plus n raised power x. So n is the power, x is what we have here. So in this case now, n is 10, x is the value that we have here. This is x, and this is n. Just put it there and get your answer. Then let me solve the second one, and we close for the day. B is when we have 4.013. This same thing as saying this can be expressed as 4 raised power 3 into brackets 4.01 divided by 4, everything cube. Look at it. the value of x in the linear approximation of 0.0025. That's what I'm going to get here. Then if I solve that, I'm going to get 64 into bracket 1 plus, when 3 multiply that, I'm going to have 0.0075. Then this here, I'm going to have 64 multiplied by 1.0075. Then if I use 64 to multiply this, I'm going to get 64.48. And that's what I'm going to get. So I would love to stop the class here. So let me just go over the recap of what we have done. When we started from binomial expansion theorem, and I introduced Pascal triangle. I said there are two methods. If you want to expand the factor that has the higher power, you can't just be multiplying. I said for us to be able to get the coefficient, there are two methods that we can use. The first method is the Pascal triangle. We use the Pascal triangle to generate the coefficient of the expansion. So once you generate the coefficient of the expansion, then the first factor, the first term that we have in that factor will be decreasing with that power. The second term will be increasing. Then I said if you don't want to use Pascal triangle, we can use the binomial expansion formula. Then that's under that binomial expansion formula. For us to be able to generate the coefficient, we make use of the combination. So we are still going to talk about permutation and combination. Then combination simply means selection. And I said if you have n combination R, it simply means n factorial all over n minus r factorial. So we use that combination to be able to generate the coefficients. And I said that the binomial expansion formula is superior to the Pascal triangle in the sense that if the power that we are given in that factor is more than 5, say 10, 20, that is the limitation of Pascal triangle. But when we have the binomial expansion formula, even if the power is raised to minus, it can even be minus or fractional, we'll still be able to use that. So I would love to stop the class now. Thank you for listening.